Assalamu alaikum, students and friends. This is part 3 of the lecture series on periodic properties of elements. Which do you think is bigger in size, an atom or its ion? You're gonna find out the answer in a short while. Just hang on, watch and learn. The given question is: refer to the electron configuration of the following species, then arrange them from the smallest to the largest. We have magnesium positive 2 ion, a sodium positive 1 ion, a neutral neon atom, a fluoride negative 1 ion, and an oxide negative 2 ion. Each one of them has a configuration of 1s2, 2s2, 2p6. If you recall, one of the properties of elements discussed in part 1 of the series was atomic radius of a chemical element, which is a measure of the size of its atom, usually the mean or typical distance from the center of the nucleus to the outermost isolated electron. It was stated that going across any period in the periodic table, the atomic radius decreases due to the increasing nuclear charge. From left to right within a period, the number of protons in the nucleus and the number of orbital electrons of the respective atoms increase progressively. For example, in period 2, the first element is lithium. Okay, lithium has an atomic number 3, and it has 3 protons, which attract the single outermost electron towards the nucleus. Okay. Second to lithium is the element beryllium with atomic number 4. Its 4 protons also attract its 2 outermost electrons with a greater electrostatic force towards the nucleus, causing a decrease in the atomic radius for beryllium. Still farther to the right within the same period is the element boron with atomic number 5. Its 5 protons attract its 3 valence electrons with a much stronger force, causing it to have a smaller atomic radius compared to either beryllium or lithium. Since the valence electrons in the period are all defined in the same main energy level, they are pulled closer to the nucleus as the nuclear charge increases, causing a decrease in size. For elements within a family or a group, atomic radius increases from top to the bottom. Example, hydrogen element has one electron in its main energy level, and it is attracted by a single proton towards the nucleus. Right? Second to hydrogen in group 1A is, of course, the element lithium, which is a light metal. Its atomic number is 3. And its valence electron is, of course, equal to 1. Now, going down in this group, we have the light metal sodium with atomic number 11 and 1 valence electron. Compared to both lithium and hydrogen, the nuclear charge of the sodium atom is much stronger, and its 11 protons should have a much greater attraction on its single valence electron. However, due to the buildup, okay, of an extra energy level and the screening effect of the 10 inner electrons, its atomic radius is greater, right? So, screening effect means the attractive force from the nucleus diminishes and the repulsive forces of the electrons dominates, and this causes an increase in the atomic radius. And so we ask the question, which is bigger in size, a neutral atom or its ion? Well, it depends on whether the ion is positive or negative. And the rule says the greater the positive charge, the smaller is the species because the electrons are more tightly held. The greater the negative charge, the larger is the size of the species. The addition of more electrons will increase the repulsion among the electrons. Let's look at the case of the light metal lithium, all right, with its atomic number 3. When it ionizes by losing its single valence electron, it becomes a positive lithium ion, right? So its remaining 2 orbital electrons will be attracted more by the 3 protons, causing it to decrease in size. Now, for a nonmetallic element in the same period as lithium, such as nitrogen, all right, with atomic number 7, its valence electron is 5, all right? And when nitrogen ionizes by accepting or absorbing 3 electrons, it becomes a negatively charged nitrogen ion. All right? Notice that the nuclear charge remains unchanged. Right? Uh, the neutral atom has 7 protons in the nucleus. When it ionizes into a nitrogen -3 ion, the protons remain intact, the 7 protons in the nucleus. All right? So, um, the force of attraction from these 7 protons will be outweighed by the repulsive forces of the 10 outermost electrons. All right? Causing the ion to increase in size. Finally, we now answered the given question. We are to arrange the following species from the smallest to the largest. All right? The two positive ions, two negative ions, and the neutral stable atom neon are represented by their respective electron configurations. Notice that at a glance, they are all identical, right? We can also use the shortcut expressions for each of these configurations. For both the positive magnesium and sodium ions, we include the outermost energy levels 3s, which are both empty because the valence electrons of both magnesium and sodium are lost during ionization. But for emphasis, we use the symbol 0 to mean that these orbitals have no electrons. And in the case of the negative ions, all right, the bracket helium is used to represent their two inner electrons. And notice that both fluoride and oxide ions have the same outermost configuration. That is 2s2, 2p6. All right? Now, the 5 elements mentioned are highlighted in this uh, sample of a modern periodic table of elements. So, there is sodium and magnesium belonging to the same period, as well as oxygen, fluorine, and neon belonging to the same period, which is period 2. The relative positions of the 5 elements in the periodic table is as shown. All right? The neutral neon gas atom must be bigger than the positive sodium plus 1 ion. A positive ion like sodium must be smaller than a neutral atom due to 1 electron loss. All right? But the same nuclear charge, since the 11 protons are still intact in the nucleus, causing it to decrease in size. And compared to a neutral neon atom, though they have the same 10 orbital electrons, the nuclear charge of sodium positive 1 ion is much greater. Consequently, its size must be smaller. However, compared to a negative fluoride ion, a neon atom is smaller in size. And it is because the negative fluoride ion has acquired or accepted an additional electron, making its number of electrons in the outermost energy level equal to 8 electrons. Okay? The same as that of the neon uh, atom. And this results to a greater repulsive forces among the 8 electrons. And with less nuclear charge, because only 9 protons are in the nucleus, this causes the atomic radius of the negative fluoride bigger, all right, than that of the uncharged neon atom. We can also conclude that magnesium positive 2 ion is smaller than sodium positive 1 ion. Hence, it follows that magnesium positive 2 ion is also smaller than the neutral neon atom. All right. Likewise, uh, oxide negative 2 ion, okay, must be bigger than the negative 1 fluoride ion. Right? So that our final answer, uh, arranging them from smallest to the largest, we have the smallest is the magnesium positive 2 ion, all right, followed by the positive sodium 1 ion, and then the neutral neon atom, and then the negative 1 fluoride ion, and the largest of them all is the oxide negative 2 ion. And that concludes our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.